Hello dear students, welcome to my channel Spectrum. I'm Mukul sir and I'm teaching you physics. So if you are preparing for a NEET, JEE and if you are preparing for your board exam, so this video is going to be very helpful to you all. So let's start our lessons, our class without any further delay. So I'm going to start the first chapter. Uh, that chapter is Kinematics and Kinetics. So my chapter name is Kinematics and Kinetics. So what is kinematics and what is kinetics, that we have to understand first. Okay. So people used to think that kinetics and kinematics are like a grammar of English. Okay. Like grammar, without grammar we cannot read and write the English. And so like grammar is very important to know, to speak English properly, to write the sentence properly. So similarly, to know the physics, kinetics and kinematics is very important. So that was the concept, but later on the people concept has been changed. Like normally, like not changed, like in physics, in kinematics and kinetics, normally basically we learn about the motions of the object and the force that causing the motions. Okay, so kinematics and kinetics is a branch of physics which deals with the motion of an object and the force that causes the motions. Okay, so this chapter comes under your physics, that is called the Newtonian physics, or we call it as a classical physics. Okay, so this is a kinetics and kinematics is a branch of this Newtonian or classical physics. So as I said you clearly, grammar, it is a grammar of physics. Okay, under that we learn about the motion of an object and force that cause the motion. Okay, clear? Now the next thing is, let us how this kinetics and kinematics comes, let us go deep into that. First we'll have the mechanics. What is mechanics? Mechanics means like the motions, okay, related to the mechanics and motions. Number one, mechanics can be divided into two groups, into two parts. Number one is dynamics and number two part is statistics. Okay, so we have two parts of mechanics, like number one is dynamics, another one is the statistics. What is dynamics? Dynamic means like with the term only it is very clear that dynamics means which is in motions, static means which is at rest. So in dynamics we learn about the motions which is due to the force. Okay, so motions due to the force. What type of motion will be it, that we will learn in the dynamics. Okay, and in statics we will learn about the rest on applying a force, a certain force. Here maybe you are thinking that how an object will be at rest even if you are applying a force. Yes, object will be at rest whenever you apply the force, not always, but in some situation. Like just imagine I am pushing the wall. Okay, that time my force will not be enough to push that wall. That time even if I am applying the force, still the object will be in rest. So that is a statics. Okay, that comes under the statistics. So that is a type of motion, that is a type of thing which comes under that statistics. Okay, but in dynamics whenever you apply the force, there will be motions on the object or the body. But if you are applying the force but still the body is not moving, that comes under the statistics. Okay, so next thing is, if you break into that, if you go deep into that dynamics, you will get two parts of that dynamics. Number one is the kinematics, and number two is the kinetics. What is kinematics and kinetics? Now we come to our main topic, no? So our chapter was kinetics and kinematics, and now we came to that main thing. What is kinematics? Let us discuss one by one. In kinetics we will deal with the motions only. We'll deal only with the motion. We will not care about the force which is acting here. I just want to tell you again, we in kinematics we are not going to we're not going to deal about the force. We are not going to take care about any the force acting on the object. We are just going to learn discuss the motions of the object. What will be the motions, how far will be the motion, how much time will it take to cover certain distance. So that all comes under the kinematics. Do you understand that? So in kinematics basically we'll just discuss, or we'll just know that about, we will just learn about the motions only, not regarding the force. How much force you are applying doesn't matter. What matters is that how far the body moves, how much will it take, that comes under the kinematics. So kinematics example, like we can say about the displacement or distance, like velocity or speed and acceleration. So this all comes under the kinematics. Then what comes under the kinetics? That is the thing. Okay. So in kinetics, we'll not only discuss about the motions but as well as the motion, as well as the force that causes the motions. That causes the motion. Yes, motions and force that causes. Okay. So here we are not going to discuss only about the motion, but we have to think, we have to know due to which force the body is in motion, or it is in coming to at rest. Okay, not rest. Let us say only motion. Okay, like example, a basic example is like if I throw the pen, you know, if I throw this marker, what happens to the marker? It will fall down. Why? Because as soon as I lift the pen, the marker from here, it will fall under the effect of the gravity. So which force is acting on the marker? Exactly, the force is gravity, and instantly it comes under the motion. So due to the gravity, the this marker comes under the motions. Okay, so here we discuss about the motion as well as the force that acted on the marker. Okay, similarly we can consider any other examples, like what to say, you know, like if I hit this, if I hit this marker, the marker will go this side. Why it is going? Because I'm pushing, or I'm applying some amount of force in this direction. Yes or no? As well as not only that force, it is causing a motion. So that comes under the kinematics. So basic example is like gravity. Due to gravity we'll have the motions, as well as we have the force also here, no? So like other example, what we can say, like momentum is also one. Okay, so etc. So that is the thing. So if you want to take the notes, please take it. Okay, now the next topic will be my body and particle. Basically when we are talking about something like mass related to that, then either sometimes we'll talk about the body or an object or the particle. Yes or no? So but what is the difference between the body and the particle, that we have to know. Okay, basically if you talk about the body, it contains like volume. It has, well, it will have a volume. It has volume. Hmm? It has volume, it has shape, it has mass, etc. It has three things like volume, shape, and mass. Like this marker, I'm again taking the example of this marker only. This marker has a volume, this cylindrical shape, so of course it has a volume. What will the volume? Pi square r, pi r square h. What is the shape? Shape is cylindrical shape, and also it will have the mass. So if any particular things like have this kind of things like volume, shape, and mass, then we call it as a body. Okay, then what is a particle? That is the question. That is the next question. Okay, particle will have only one thing, that is the mass. Okay, it will have it is very tiny in tiny in size. That is why size is almost negligible. So if the size is negligible, shape no shape, volume is also almost zero. So particle will have only the mass. Okay, it will have a negligible amount of size, negligible amount of shape. That is why it has no volume and shape, so it will has only mass. Okay, so that is the thing. Now the next thing is rest and motion. What is rest and motions? That is very simple, no? Rest means something which doesn't change its position with respect to time. Rest means like, this boat is in rest because it is not changing its position with respect to time. Time is passing, from the beginning of the time when I was teaching, the boat was here and still it is here, so it is not changing its position. That is why the boat is in rest. So rest, if a body or object does not change its what position with respect to WRT time, it is said to be in rest. Clear? Example, book on the table. Okay, now the next thing is motion. Just we have to change here only, like if a body changes its position with respect to WRT, with respect to time, it is called, it is said to be in motion. Clear? Example, a moving train. A moving train, like here also I am moving, here also I am moving, so I am also in motion. Okay, rest means if a body doesn't change its position with respect to time, it is called as is said to be in rest. Like book on the table, it is never going to change its position with respect to time, that is why it is in rest. Now what is motion? Motion means like if anything will change, or anybody will change the positions with respect to time, then the body is said to be in motions. Like a moving train, the train was moving, and like this is my train, this is not actually train, but let us say this is a train. This is moving, this is moving, this is moving with the respect, or with the passes of time. This is also changing the position, right? First it was here, now right now it is here, so it is changing its position, so that is why it is a motion. But I'm asking you one questions. You are we are on earth, no? So like for us the building, the trees, all are at rest. But do you really think that trees, that buildings are at rest? Let us say, to answer this, let us consider the situations. Now let us move away from the atmosphere of the earth. Okay, let us go out of the earth atmosphere. So this is my earth. Let us go outside the atmosphere of the earth. Now we are here. Okay, exactly, we are outside the atmosphere of the earth. So this is my atmosphere. Okay, now, and this is my earth, this is my tree, this is my building. Okay, this is my building. If you are if you are on the earth surface, and for you this building, this tree is are all at rest. But what if you go away from the earth atmosphere? Now just imagine, just close your eye and try to imagine you are just outside the earth surface, and try to look the earth, the whole earth. Now what you will see, you will see that the earth is moving. The earth moves then around the sun also, as well as it rotates around its own axis also. So that means earth is not in rest. Then how can you say the trees, the buildings, everything, the road, that car, everything is in rest? That is the question. So do you think now the building trees are in rest? I say no, because they are not in rest now. They are not in rest because with respect to us, first it was in rest, but now right now it is not in rest. What matters is that where are you, okay, where are you and what are you looking, that depends, so that matters a lot. First you're on the earth surface, that is why for you that building and the trees were at rest, but now you are not on the earth surface, you're outside the earth. So for you now, right now, the for you everything is in motion, whatever is in the earth, everything is in motion. So I must say there is no such terms like absolute rest or motion. There is nothing which is absolute at absolute rest or absolute motions. So then what type of motion or what type of rest is that? Because for us right now, for us this boat is in rest, but if you go away from the earth atmosphere, the same boat will be in the motion. Then what type of rest or motion is it? So that time we have to answer it like it is a relative rest or relative motion. So that we have to know. So we always have we all whenever we talk about the motions or race, we always talk about the relative rest or relative motion. What is relative rest or relative motions? Like whatever the surrounding is here, around that particular thing, like for me my surrounding is this wall and this board, no? So with respect to that wall, that board, I'm at rest right now, so if I start moving from here, I will move with respect to the wall, I'm going far away from the wall, I'm going very close to the wall or to the board, right? That is called the relative motions, okay, or relative rest, okay. So what if you are talking about the rest and motion, always talk about the relative rest or motion, not about the absolute rest or motion, because there is no such term like absolute rest and absolute nothing is in rest, because the whole universe is also in motion. So we must say there is nothing which is at absolute rest, only there will be relative rest and motion, okay. Now the next topic will be motion in one, two, or let's say not right, or and three dimension. Motion in one, two, and three dimension. We have the two, one dimension, two dimension, and three dimension. What will be what type of motion will be there in one dimension, two dimension, and three dimension? That we will discuss about that. One dimension means basically it means either it is x axis or y axis or z axis, okay. So we have to consider only one axis. Now if anything is moving towards this x axis or away from the x-axis, like we'll have the two axes, no? For x also we'll have the two axes, that is one is positive, another one is the negative. Origin to the right is positive one, this is a positive, and origin towards the left is your negative. So whenever the object is moving only along x-axis or negative x-axis, or y or negative y or z or negative z, that time the motion is called as a one dimensional motion. So I will write 1D motion. What is 1D motion? So here basically the object will travel in a straight path, so we called it as a rectilinear motion. Do you understand that? What is rectilinear? Rectilinear means moving in a straight path or a straight line is called as a rectilinear motion. So one dimension motion is a rectilinear motion. Why it is a rectilinear motion? Because in that particular case an object or the body is moving only in the one axis or in a straight path, that is why it is a rectilinear motion. Like, can you give example? Yes. So example is a car moving in a straight path. So that is a one dimensional or 1D motion, okay. Now the next thing is 2D motion. 2D motion means two dimensional motion. What is 2D motion? Like if an object or body is moving in a plane, either in the xy plane or in the yz plane, either it can be in xy plane or yz plane or zx plane, so that motion is called as a two-dimensional motions. Okay, what is a plane? Plane means like I have a x-axis, here is a y-axis. So this whole particular thing is my, this particular region is called as a xy plane. Okay, this is my xy plane. Similarly, you can have with other planes also, like you can have a yz plane also, you can have a zx plane also, but right now we are considering only one plane, that is yz plane. Okay, so any object moving only in a plane, that is called as a two-dimensional motion. Can you give example of two-dimensional motion? Like just imagine an ant is moving here. Okay, don't consider it is moving in a straight or vertical or exactly horizontal. Let us say it is moving like this. How it is moving like this, sorry, and is going like this. Okay, okay, this is my ant. There are so many. Okay, like, four legs, six legs. Okay, so it is moving like this. So now with that time, with the passage of time, it is covering x-axis also, it is moving towards the y-axis also. Similarly, and another time it is moving another distance of x and another distance of y. So that means this ant is moving in a x as well as the y axis, that is why at the same time together simultaneously, that is why this type of motion is called as a what, is called as a 2D motion. Okay, so example, and moving a wall. Okay, so that is the example of 2D motions. Now the next thing is, the last thing is the 3D motion. What is the third motion? 3D motion. 3D motion means whenever an object moves with respect to xyz plane, sorry, xyz axis, like here, this x, y, this my, let's say this is z. Now just imagine I have something with respect to this my axis, I have something here. Okay, now with respect to that, my position of that object will be how much? Something with the x-axis, something with the y-axis, and something with the z-axis. So this type of motions is called as a three-dimensional motions. Can you give example of three-dimensional motion? Yes, like a bird, if a bird is flying, okay, a bird is flying, so that is also kind of example of three-dimensional motion. Bird flying. Why it is a three-dimensional motion? Because while flying, it will fly with respect to x-axis also, it will fly with respect to y-axis also, as well as it will fly with respect to z-axis also. That is why it is a three-dimensional motion. Clear? Now, from the beginning only, we are saying, like, we are talking about something is moving with respect to again and again. Yes. So, but what is that? What is that respect to with respect to? So, with respect to here is actually the reference frame. Okay, so what is reference frame? Reference frame means it is a fixed surroundings. Okay, fixed thing, a fixed surrounding with respect to which any object will change its positions. Okay, or will remain fixed. Okay, will not change its position or will change its positions. Okay, like with for me, this wall can be my frame of reference. Okay, because with respect to that I will change my positions. Like, let us say exactly right now I am 1 meter distance from the wall, or this from the board. Okay, and right now my distance has been 2 meter with respect to that wall or the from the board. So in that case, we can say with respect to that wall or the board, I change my position. Yes or no? So for me, that time, for me, this board or this wall will be a frame of reference. Okay. So what is the frame of reference? it is a frame with respect to which an object will change its position. I know. So it will change its position. Yes. I know it will change its position with respect to time. That is why it is a frame of reference. Okay. यो भयो एउटा कुरा. Okay. Basically, we'll have the two. We'll discuss here. We are going to discuss only about the two types of reference frame. That is the 2D reference frame and the 3D reference frame. Okay. So let us discuss one by one. 2D number one, or let us write first. Types of reference frame. Normally we'll have two types of reference frame. Number one, we'll discuss about the 2D reference frame. Okay, and number two is your 3D reference frame. We'll discuss one by one. Okay, so with that, copy the notes also. Don't forget to take the notes. Okay, because keeping the notes is very important when you will do the revision. That is very important. Okay, concept you will get from here, and the revision part you have to do yourself. So for that you need the some support, and that support is your will be your uh, this revision work. Okay, so that is why keep the notes. Okay, so in 2D reference frame, okay, we'll have the two types of 2D reference frame. What are they? Number one is the Cartesian coordinate frame, and number Cartesian reference frame, and number two is the polar reference frame. Okay, so we'll discuss one by one. Again, here also we have two types of reference frames, that is the Cartesian reference frame, and the one is the polar coordinate form reference frame. So first we'll discuss about the Cartesian reference frame. In Cartesian reference frame, we'll discuss about the xy coordinate only, like xy or yz or zx coordinate. Okay, so let us say an object is here. An object is here. Okay, first it was here. Its position was xy, x1, y1. Right. Right now, the first object is here at point P, and with respect to x, its coordinate is x1, and with respect to y, its coordinate is y1. Okay. Let us say this is x1, this is y1. Now, if the object will reach at another point, that is Q, that time its coordinate will be x2, and then with respect to y, it will be y2. Okay, so if you are here in the 2D reference frame, like in xy frame, that time this type of coordinate is given by the Cartesian reference frame. Okay, so this xy frame is normally is called as a Cartesian reference frame. Okay, and the main thing is how to find the distance, in the what will be the distance of the object. So like for our first object was here at point P exactly, and now the object is at point Q. So after some time it changed its position from P to Q. So what will be the distance it covered from P to Q, that we have to find. Okay, so in Cartesian reference frame normally we will find like using the distance formula, like PQ is equals to square root of x2 minus x1 whole square plus y2 minus y1 whole square. So that will gives the distance of the object. Okay, when it moves from point P to when it moves from P to Q. Okay, so this is called the, this is all under the Cartesian reference frame. Okay, so the next reference frame for the same 2D is the polar reference frame. So in polar reference frame, normally will denote the position and of an object by the coordinate like r and theta. But what is r? R is the linear distance from the origin, and what is theta? Theta is the polar angle. Okay, so what is r? R is the distance linear distance from origin, and theta is equals to polar angle. Okay, so these are the two things. So with respect to that two things, that is two coordinate r and theta, we can find the positions of any object in the xy in a two-dimensional case. Okay, so this is my x, this is my y. Okay, what is x? X can be written as r cos of theta. Hmm. Why? How I am writing x is equals to r cos of theta? Because if you consider this as a right angle triangle, okay, this is a right angle triangle, and this will be the hypotenuse. Yes, this r will be the hypotenuse, and with respect to this polar angle, this will be the base. So how will write the base? Base means equals to, like, which trigonometric ratios you are going to consider here, that is, and that is the cos. And cos is equals to, cos means q, it is x by, that means base by hypotenuse. So that is why x is equals to r of cos theta. No, enough. This is in a, y will be equals to r of sine theta. But why? Why is this? This is the y. Yes or no? And y will be equals to r of cos sine of theta, because now right now we know the we know the hypotenuse, we know the perpendicular. So with respect to hypotenuse and perpendicular, we have to use sine, trigonometric ratios. No, so sine is equals to y by r. So y is equals to r of sine theta. Here. So now, what if I square and add these two equations? Let us say equation 1 and equation 2. If I square and then add, while adding and squaring, we have to add with the left hand side with the left hand side, and right hand side with the right hand side. So it will be r square cos square theta plus r square sin square. So it will be equals to x square plus y square is equals to I square. So r will be square is equals to square root of x square plus y square. So this will gives the linear position or positions of that point P from the origin. So this is going to give you the positions. Okay, now the thing is, the next question is, what will be the uh, and what that because this is not only, this is not sufficient to give the exact location of the object or the body at that moment. So for that we need some angular concept also, that will give by the, polar angle. So how it will give the polar angle? Why I'm writing tan theta? Because if I divide this and this, this by this, like if I divide equation 2 by equation 1, if I divide equation 2 by equation 1, it will be y by x is equals to this by this, means r and r. So 2r and r will cancel each other, so I'll have sine theta by cos theta. Yes, sine theta by cos theta is actually the tan theta. So tan theta or theta is equals to, if you take this tan to the right hand side, it will be tan inverse theta. So that will gives the tan inverse y by x. So that will gives the complete information about the object in a 2D reference frame. Okay, with using how do you find that? By using a polar coordinate. Okay, so if you use the polar reference frame, also you can find the positions and the positions of the object at a particular instant of the particular moment. Okay, so it is not that every time you have to use the Cartesian reference frame only, but if you know the positions, the distance from the origin, or the polar angle, with respect to that, you can easily find the position of the object. Okay, but for that you have to find the positions from the center. Okay, what is distance from the center? Number one, how to find r is equals to square root of x square plus y square. Another one is the polar angle. So theta is equals to tan inverse y by x. Okay, so these two equations actually correlates or relates with the Cartesian coordinate, because what is r is my, it is a coordinate in the polar coordinate and polar reference frame. And what is theta? Theta is also coordinate in the polar reference frame. But what is my x and y? It is a reference frame, it is a reference coordinate with respect to the Cartesian reference frame. Here is also y and x. So these two equations, like this one equation, r is equals to square root of x square plus y square, and this theta is equals to tan inverse x square x by y by x. They actually relate with the uh, polar coordinate with the Cartesian coordinate. Okay, so that gives the actual relation. So this is this much for today. Okay, we will come back with the next thing, that is the three-dimensional reference frame and many other topics. Okay, we are going to cover in our lessons or in our class. So please keep watching my channels, and let's learn and see the video as much as you can do with your friends. Okay, or with your brothers, sisters, whoever you have. Okay, so please share and then like, subscribe my channel. Okay, thank you very much.